It works on my machine. That's really interesting. One of the most interesting responses in the history of programming. Welcome to Docker Crash Course, where we will be answering some of the most important questions about Docker and how it's solving it works on my machine issue. Also, why it is important to learn Docker. If you are a student who would like to set up a learning environment for your programming language, for example, or you are a developer who would like to use a specific piece of software or technology without installing it locally, Docker for sure will help you. Also, is going to make your development daily life much easier by removing the headache of configuring, adjusting development environment for your task. More insights. You are a front-end developer and you would like to have a specific data from the backend. So your backend team can provide you with a Docker image that you can build, start, and then voila, you will have access to the backend data you are looking for. You are a backend developer, in fact, and you would like to work with a specific database, cloud service, without the need to configure or download them onto your local machine. So you can do it with Docker. Hands-on example will be provided using Java, Spring Boot, HTML, and maybe partially will be Angular as well to see how the communication is going on between the backend and front end. Using database Postgres for Docker volume and data persistence. Then using Docker Compose to run several Docker containers in a sequence. Don't worry, we will not write any complicated code. The course is about Docker, not a specific programming language. We will explore several important Docker commands such as Docker container, image, inspect, volume, and more concepts to make Docker easy to use on a daily basis. Links to the project, repo, and presentations will be in the description box below. The course is divided into sections so that you can skip any part or jump directly to any part you want. Be patient with the coding part, repeating them if you need. The course is designed in a manner that will guide you from zero to advanced level until you can use Docker on a daily basis. Please prepare your pen and paper and let's get into Docker. The agenda is so simple. In this crash course, we are going to answer together the following questions, and not only those questions, not just theoretically, but also hands-on experience to solidify our knowledge. What is Docker? The bigger image of Docker. Why to use Docker? And some key Docker concepts and building blocks. Dockerizing a Spring Boot application. Docker volume and how to use it. Docker Compose and how to use it. But before getting into command line and getting our hands dirty, let's agree to know some theory and reasons behind Docker. I will do my best to make it interesting and useful. What is Docker? The big image or the big picture. To know what is Docker, we must know what problem Docker solves that led to inventing it. The problem is simple, it works on my machine. Wow. Software depends on its environment, the operating systems, installed libraries, language runtime like Java, and configuration files. Differences between a developer's laptop and a production server cause bugs and failures. The old solution, virtual machines. Virtual machine is a computer or a complete virtual computer running inside your real computer. It has its own operation system, which is heavy per gigabytes, slow to start, and resource intensive. The new solutions is to use Docker. Docker is an open source platform that uses containerization technology to package an application with its dependencies, libraries, and everything and make them as a container. That container is isolated and is lightweight. This container can run reliably and consistently across any environment that has Docker installed, from a developer's local laptop to a production server. To provide you with an example of how powerful it is, let's say that you have a PC and would you like to learn operation system like Linux? What should you do? Usually, you will need somehow a virtual machine to install the operation system, and that will be sometimes hard for beginners and resource intensive even for advanced users and your PC as well. But here is Docker comes into picture. Let me provide you with a hands-on example to do that in Docker. Don't worry, we will get into how to set up Docker and step-by-step guide of using it for your daily development and your professional and preferable tasks as well. Let's have a simple example of using Docker. Come in. Part of the code to have one example before we get deeper into Docker, how Docker is working. So let's get our command line and we will make a quick demonstration of what if you would like to know more about Linux, but in fact you have only operation system as Windows and you don't need to install, you don't want to install any virtual machine or any overhead like this. Using Docker, just let's say Docker run, and then you choose the version of your Linux distribution. Let's say we'll use Ubuntu. Ubuntu is by you, Ubuntu, and let's say the 2.04. And as a quick execution, let's say that cat to print, and we will say from etc we would like to get the operation system release. So here we are. Let's enter and double check what's going on. Unknown command docker run. Yes, for sure, because I should run docker run. My typo. So enter. Unable to find this image. That's a moment when Docker will not be able to find this image locally, then it will search it online. So now let's check exactly what's going on. Once the image status downloaded newer image and already the version, as you can see, it is 2.4. Let's make it once more and run. I still have the same name Ubuntu and all the information about the operation system I am running. That's in fact how you can use Docker in a simple word. Why to use Docker? The motivation behind it. You can use any application in seconds without any need to configure it locally. It's great for learning and local development and even for production. Consistency. Eliminates works on my machine problems. The containers you built is identical in development, testing, and production as well. Isolations. App run in separate environments. A library conflict between app A and app B is difficult to occur. Portability. Run anywhere Docker is installed. Mac, Windows, Linux, cloud servers, or whatever. In the space, maybe you can. The environment is defined by the image, not the host. Resource efficiency. Containers are lightweight, megabytes, not gigabytes like virtual machines. So you can run many more apps on the same exact hardware. Simplified for DevOps. Containers are the perfect building blocks for modern CI/CD pipelines and orchestration systems like Kubernetes. Key Docker concepts and building blocks. Before demonstrating the Docker workflow, let's get familiar with building blocks terms. So it will be easy to go along once we start getting deep and deep. Also, we are repeating this information in more details during presentation parts. Please type those concepts down to use them as a reference during the course and in case you forget one of them while we are working together. Docker image. Docker image is a read-only template with instructions for creating a container. It's a snapshot. It's just the recipe or a blueprint. Docker container. A runnable instance of an image. You can start, stop, or delete containers. Container is the running process built from the blueprint. Dockerfile. A text file contains commands like from, copy, run, cmd, etc. to build an image. Docker engine. Docker engine is the core software installed on your host that builds and runs container. Docker Hub or Registry is a service for storing and distributing images. It's something like GitHub for code. Docker Compose. Docker Compose is a perfect tool for defining and running multi-containers applications. You use a Docker Compose file, it's YAML file, and then to configure it and configure your application servers and services as well, like your app, database, server, etc. Then boom, your whole system is running just using Docker Compose. Docker Volume. Volumes are a way to store data outside a container lifecycle on the host machines, for example, because if we remove a container running a database, all your data is lost. Docker networking is primarily a way to facilitate communication between containers and manages isolation between different applications. It is not a full-featured enterprise firewall or advanced networking security tool. Take note that the command line CLI is the universal, reliable, and most powerful way to work with Docker. The graphical user interface is a helpful management dashboard on top of the command line interface. Docker runs the container inside the lightweight WSL2 Linux environment. This provides much better performance and compatibility than running Linux containers directly on Windows. Your Windows file system is seamlessly mounted in WSL, allowing easy file sharing. Now it's time to use an animated presentation to present to you visually how Docker works under the hood. So let's get in. Let's jump into the presentation. We are going to start by the most famous comparison between container as a Docker and virtual machine. You can see from the image here the differences. The Docker engine is built on the top of the operating system. The same infrastructure is used, but the operating system is shared among all other containers. But in the virtual machine, we have hypervisor and we have specific operation system per application or per app. Let's jump into the infrastructure. What infrastructure we are using? Infrastructure, it could be anything where you are deploying your application or where you are deploying your operating system to run your application or where you would like to use Docker engine. If it's on a server or on your local machine or on your cloud host. Then we have the operating system itself. Operating system is where you are running Docker itself. So it could be Linux, Windows, or Mac. We jump into Docker engine. Here you have to mainly focus of what is going on here. So Docker engine, in a simple word, is just open source containerization technology that allows the developers to build, package and deploy application in containers. What is exactly Docker engine is doing? First of all, it will build the container. You build the container from an image already. This image you have it locally or you will download it from somewhere online, which we call it Docker Hub. After that, we ship the container. Shipping the containers mean after you finalize your container, you can push it back into some online storage by using Docker push to share this image with your team or with the world as you like. Then running the container. Docker run command, it will responsible for running the container. If you have it locally, it will run it. If you don't have it, it will communicate with online like Docker Hub registry to get the image from there, then it will be running. So that's the Docker engine responsibilities. But let's get into more the Docker engine, how it looks like. So as an infrastructure, Docker engine itself as a containerization technology is mainly a client server technology. So that's client server technology, you need a server. Docker daemon acting as a server. REST API, command line interface are acting as a client. The command line interface it's using to interact with the Docker daemon. Also, REST API is used by applications to communicate with Docker daemon as a server. REST API means that you can access Docker daemon using HTTP client. Then we have the Docker daemon itself. Docker daemon itself is responsible for persisting the background process like managing the Docker containers, the image, volumes, all this running stuff will be handled by Docker daemon. Also, it's will listening to Docker API. If there is a call coming from any REST API, it will be also done by Docker daemon. And it will communicate with other daemons to manage Docker services. Even it will also communicate with registry to get your application. Then we will jump into the application itself which you are running. Application in that case, it will be a container containing your application and the dependencies required to run your application. And all of them are sharing the same operating system as a lightweight container. Let's jump into Docker workflow. How Docker is working, in fact, under the hood. What is going on when you are as a client communicating with Docker as host or as a server. So to understand the Docker workflow, let's first of all divide it into three main sections. The three main sections will be client, and we have the host, and we have the registry. Client that you will use to communicate with the host. Registry is the place where we are storing images to using them later by any Docker's containers all over the world. So the client, it will be something like command line interface, or remote API, or even Docker desktop. The host, it will be the daemon, your server. Daemon will manage the containers, will manage also the images you have them locally. Registry is the place where you are storing these images online so you can later on use them in different places all over the world and you will not be linked to local registry. The moment that you start as a client or using the command line interface to communicate with the daemon by sending one of these commands like docker build, docker pull, docker run, that's going to end the Docker daemon, the server. Docker daemon, once you communicate with it asking for some images, it will going to check this image locally first. If it's found this image, it will turn it into containers because container is a running instance of an image. After that, if it didn't find this image, that means that we need to communicate with a registry, with something online. That registry is configured when you configure your local daemon or your server so that you will tell the server where to look for an image. And then the Docker daemon will communicate with the registry asking for that image. And if the image existing in the Docker daemon will download it into the images locally, and then will create an instance of that image to be a container for your application. That's in simple word how Docker is working. Let's get into the hands-on. See you there. Let's also Dockerize something, a single stage style and then multiple stage style. Let's get them. To make the installation, we would like to visit Docker website, the official website. It has the installation, what we are looking for. In Google or in Bing, whatever your search engine you are using, you can just type Docker download and that's it. You will get something like this, www.docker.com. Just double click it and then you will visit Docker. You need Docker desktop to be installed on your machine. So in that case, you will be able to run Docker image and containers. First of all, let's download Docker. We are going to download Docker for Windows. So you have two options, Windows for AMD 64 or ARM 64. You should know exactly what architecture you have in your machine. Quickly, to know which one do you have in your machine, you can just visit your system, clicking on the Windows icons and then settings. From settings, you get home, but you need to check systems. From systems, you can check about. From about, you will see here exactly what architecture do you have. x64 based processor, it's Intel, or x64, which will be AMD. So one of those will be enough for you. In that case, we are heading back to our Docker because now we know exactly what architecture we have. So we will use AMD 64. Download it. Just a minute once it's installed. I have it already. That's what I can see. So let's open the downloading folder. From the downloading folder, because I have it already before it was downloaded, I will install it. Just launch the installer. Once you launch the installer, you will get this user account control. Yes, for sure, you know exactly what you're doing. You're a programmer. So let's get in. In that case, you will use WSL2 for hypervisor and add shortcut to desktop. Keep it as it is the configuration. Once you start the installation and you click OK, the unpackaged file will start and it will be installed. There is nothing in between. So once this one is finished, you will be able to run your application. So we have the installation succeeded. We will close it. We have Docker version 4.45. And now we will run our Docker. Here you can see your Docker desktop. If you would like to start Docker on Windows, you need to have the desktop. It's better than using the system CTL and stuff like this. Okay, so you have the Docker subscription service agreement. You can please double check it if you'd like to know exactly what you are signed for. And you accept it, you have no other option. Once you start it, you can choose the Docker, you can sign in, or you can even use it as a guest. In my opinion, it's better to have a username and password, stuff like this. I will do that later. So I'm using personal. Here you will add your email address and you will continue. If you don't have account on Docker Hub, you can just create account that should take you there and you will be able to do it. Docker using the WSL integration. WSL integration is a Linux environment where you are running your containers. That's why it's required. I have it here, so I will just restart the integration. And let's say I'm going to skip this part and I'm starting the Docker engine. Docker engine should start. Welcome to Docker desktop user interface. And that desktop user interface, you should be familiar with most of it at least, because that's where you are going to manage your containers, your images, volumes, and everything else you need in a manner that it will be much faster to start, to stop any container, to delete, and to handle them. So let's check it together. First of all, you have here the containers, and as you remember, containers is an instance of running image. You will find the list of containers here. Images that you will run, you will find them here. It's local or from my hub, that if you are registered, but I'm not connected. Volumes, when you create volumes, you know, is a place in your machine where you can store data in a persistence way. And builds, every time you build something, you will find it here. Usually, also, you need to familiar yourself with Docker in general in case if you got some issues. Resources is good for computers and operation system, laptop, whatever, with less resources, so that you can control your resources and you limit them. So, in general, that's how Docker started. Let's quickly double check from, let's enable the Docker terminal and let's make quickly Docker version and let's see which version do we have. So Docker version that we have, it's current version 2803. So how can we know exactly that Docker running from the command line? If we open our command line from command prompt and just also the same Docker version, enter here, you get everything you need to know about Docker. Let's say that you would like to know if you have images, Docker images ls to list them. So you got nothing, no image found, nothing ls. Did you mean Docker image? I'm sorry, it's my mistake. So without s. So here you can see there is nothing at all in this response. So congratulations, now Docker running on your machine. So next time we will continue how to use Docker, especially from Dockerfile. So let's see you there. Thank you for your time. Before jumping into the command line interface, as we spoke that Docker using command line interface as well as Docker desktop. Most of our commands will be in command line interface. For that case, let's jump into a quick presentation of the most important and more used commands in Docker by highlighting the most important commands that usually we use, starting by Docker build. Docker build is used to build image from a Docker file. That's it. Docker build has a specific syntax. The syntax of Docker build is you write Docker build, that's two commands, it's always fixed, and then you give an option like tag, for example /t, tag name and version. You give your image a tag name. Version, it's better to version your image all the time, so in the future if you have a new image with a new change, it will have a different version. After that, you provide the Docker file path where you are going to build image from that Docker file. Let's say something like this, Docker build /t my image, and my image will be version 1 and dot. This dot mean that I'm running Docker build from the same place where my Docker file exists. After you build an image, you would like to run it. So we'll jump into Docker run. Docker run is to run a container for an image. Docker run also is simple. You provide Docker run, and after that option that you would like to use, because we have a lot of options with Docker run. I will show you now how can you know most of the options. And then image name that you would like to run, which will have image and tag and argument if you have argument, like we did when we run Ubuntu. So now we will continue something similar. Let's say Docker run and name. We give a container name like Ubuntu container. So each container can have a unique name. So you can give this name to make it more identifiable and human readable name. Because usually Docker, if you didn't provide a name, it will auto generate a name for you. And then the image is Ubuntu. When you have a running image, sometimes you would like to get into that image to run something. Let's say check logs, check files, whatever. So to get into the image, you need to execute something within that running container. Docker execute is to run a command within the running container. Syntax also simple. Docker execute and options that would you like to run. How would you like to run this command? Container name, not image, because you would like to get into the running container. After that, the command which you would like to use within that container, whatever what it is, and the argument which you provide to that command. Let's say docker execute Ubuntu container. That's my running Ubuntu, and I would like to list all the file. The command is ls inside this bash folder. Some commands, it's considered highly important, something like, let's say, docker command and then option, whatever, because docker has a lot of command. So this cmd is a placeholder, nothing more. So command as option. After that you run, let's say, like docker container dash dash help. That means you would like to know what kind of commands that you can run within this docker container command. What option do you have there? Also the same with docker image, the same with docker volume. Let's say the docker container ls, which means docker container lists to me all the running container at the moment, or all the containers I have in that PC or the running environment. Also same with docker image, it's exactly the same, ls. Let's say that from here, remember that to get into docker command line, you need to make sure that you have a docker container in running state. So it is running, I have it here, docker is running. So let's say that docker image and ls list me everything inside this image. Now there is nothing running, so I got this output. So what if I don't know exactly what options I have when I'm running this image, like this docker image minus minus or dash help will provide me with all the available option when I'm running this docker command image. Let's see that I have docker image with build, history, import, inspect, ls, and everything else. Exactly the same with docker container, ls will do exactly the same. Docker, let's say container minus minus help will also do the same, but I wrote something wrong with word docker, so typo. So I will have exactly the same, there is nothing changed. So minus minus help, you can consider it as your assistance if you would like to get into what option this docker command can provide you out of the box. If it's difficult to use minus minus help, so I think that you can Google it. That's much easy way. Just Google. Also the same with docker. Let's say docker run minus minus help will also provide exactly the same help. So that was it for the quick. So once we get into the command line when we are working, at least you will have a glance and the preparation, what type of command we are writing, what options, and what we are going to do at the moment. So the strategy is to start slow. In that moment, we are going to start with writing so simple Java programming. You can do exactly the same for your programming language. Also, later on, we will have the same for HTML application as a quick one. Both of them will be simple. Let's get into some coding. You can follow with me even if you are not a Java developer, because everything will be so simple. Here, I have a folder already prepared to be for Docker. I'm going to create another folder within. I will call it just Java. Within this Java folder, I will prefer to open this Java using more option and open with code will allow me to do several things. Yes, I trust this also. Now I have Java folder. Within the Java folder, I would like to create a new file. I will call this one, let's say, Java. Now I have a Java file. I will have a class, that's Java syntax. I will call this class also hello. It's I think hello is double L. Okay, so that's class hello. Under this class hello, I will have public static void main. Nice. Public static. Yeah, exactly. Public static void main. That's where I will be able to print some statement inside. For Java programmer, this is the entry point. If you are not programmer in Java, each Java programmers know that Java application, it has to start with static void main as the entry point. Let's say that we'll have here 2 is out. to system print out standard. We will just simply print some stuff. Hello. Let's say hello from Docker. Okay, that will be my application. If we use shortcut, I believe that Alt Control mouse down, Alt Shift mouse down. Okay, let's make another one. Home, enter. Okay, let's also S out to print another statement. I am, that's my name. So Alt Shift F for formatting. Now I have my Java application. In fact, if I run it, it should run. I will have no issue. I will just allow the GDK. And you can see this is running locally because I have already GDK and everything prepared and installed. But what if you don't have all this stuff, but you would like to build it using Docker? That's exactly what we are going to do. We are going to introduce the Docker file. We will start by identifying Docker file. If you remember, we use Docker run Ubuntu, stuff like this from command line. But what about automated repetitive tasks? You can use Dockerfile for that point, repeating tasks. So Dockerfile is so simple. Within the same folder, Java, I will just create a Docker file application, and that's it. And you can see it even it's make the icon of Docker. First step, to run any programming language, you need to have the running runtime environment for this programming language. Dockerfile providing you by using the keyword from. As a convention, always the Docker keyword will be capital letter. So now I would like to call open, let's say GDK. I believe Docker should help me by providing, yeah, exactly. There are some stuff here, but I will open GDK, let's say 17 and GDK. There is a list already for all the GDKs that require for you. We need only the smallest one, so the slum. Now I used from to tell Docker that this image we need it. So from this image. Second step is within the Docker container, I need to have a work directory. The work directory, I will create it myself by just typing the same work. And because I have the Docker plugin is installed, I can see already the Docker like making autocomplete. If I enter, it will tell me exactly what path. As a common convention, the work directory we call it app, but in smaller case. We would like to run the Java application inside Docker. So we need to copy the Java application from my local machine to Docker. We will use just the same keyword in English and we will tell Docker to copy. But copy what exactly? Copy this file hello.java. If you have different, we will see this later, how we can copy packages or folders. So I would like to tell it copy this file. So this file is called, it's starting by hello. But remember something, when you have two things in Docker, like something locally and something inside the container, you always map by starting by what is local and then what is inside. Here I'm telling that I would like to copy hello.java to the main path of the Docker container. I copied that. Now I would like to run it inside the Docker. For Java programmers, we know that to run a Java application, you need to compile it. In that case, we ask Docker to run. We give this command. It will be running inside the container itself. So what exactly to run? We will run something, we call it Java. It's a shortcut of Java compiler to compile this hello.java. There are something we call it entry point. We need to define the command line to run when the container itself started. So once the container, you make like, let's say that Docker run, you need something to initiate this container, to start the container. That's why that's where we use CMD. And you can see it's executable. There is something to execute inside. And within this process, you will double quote and you will tell Java what exactly to run. So what to run, it will run this hello file. But remember that our convention is to use capital letter for the command line. Again, I missed it. CMD. Okay, and already the Java should be Java. And that should be it. Okay, so I have the CMD Java compile running the Java and everything should run fine and as expected. CMD, what is unknown instruction CMD? And I believe so. Now we will see. I have Docker file. In that moment, as you notice that we have file for instructions. This instruction is going to instruct Docker to build this image, to create image. So Dockerfile is used to create a local image that later on you can push to your remote repository. So now it's time to build this image. We will just instruct Docker and we tell Docker to build, but when you build something, you need to give it a name. You give this image a tag. So let's call this image hello Java. Okay, because you are using Docker build, Docker will build image from where? From a Docker file. So where is the location of this Docker file? And because we are running this command Java inside the place where is already Docker file, like the root, in that case, all what you need to do at the end is just to add dot. That's going to indicate to Docker that the Docker file is existing in the same exact place where I am running my command line. We run this and let's see what will be. Enter and let's see. Yeah, because I need to make a space. As you can see, the mistake here for this CMD is because I didn't make the space. Now we fixed this issue, so let's make CLS to clear the command line, and let's coming back to docker build /t hello Java. Now it is running, and exactly the steps of execution. When you run your Docker, you can see it. What's going on? Internal load build definition from Dockerfile and transferring Dockerfile. That's how it transferred. And there is metadata. It will be coming from where? We don't have any Dockerignore. We'll speak about it later. And now have image, exporting the image and exporting it as layer because Docker is building image layer after another. We will go into also multiple image or multiple steps layers for that. So naming the Docker container hello Java latest because that's a version we didn't version. Now it's the moment of truth. We would like to run this Docker, but let's show you something from Docker desktop. If we double checking the image, we can see already that we have image here from images called hello Java. This one 48 seconds ago, it's 642 megabytes because we include inside already the JDK itself. We will speak later how to minimize that one to be more efficient using multi-steps. And if you look here, there is a container, but this container is not working because it's my old one. If I delete it, it will has no effect. It's time to run a container. You can run a container using two different approaches. First one is using the run here and you provide a configuration, or using the command line. But let's go back to the command line part. From the command line, we will tell Docker, Docker run what exactly? I would like Docker to run in detach mode, or let's keep it not detached. So later when we speak about detach, you can know what it is. Tell Docker that run an image and create a container from that image. So our image is called hello Java. That's the Docker run which we would like to run. If you do that, that's it, and you enter, that should run your Docker container. And if you look, hello from Docker, and I am Ahmed Sami. And the reason why when I start Docker run, it works directly is because I already instructed Docker from the CMD as the entry point that once the Docker run command is triggered, please call Java to run the hello file. Also, if we double check it from our containers, now you have a containers. There is no any names. You can see you have container ID and you have some strange names over here. We will speak also later how can we name that. We can use Docker ID. Important now that you saw by yourself that even if you don't have the runtime environment on your machine, using Dockerfile you can build and create one. If you double click it, you can check the Docker itself using Docker desktop. Here already the logs which printed from the Docker. If we have some issue, you can find it also here. If you would like to inspect your container, you can check it here, but this will be a lot of information here. If you have something mounts, execution, or files, or any states that you are interested in. So you can also, this is very good idea to use that. Now already we run our Docker container using this part, I mean using the command line. So let's quickly run it also using our interface. I will delete this container, I don't need it, so there is no container here at all. So from the image, also to prove you that it's running from within Docker desktop, let's close this file. I don't need it at all. Now from here I will just docker run, and there is optional settings. Do I need any optional settings here? At the moment I don't need anything. If you would like to provide a container name, you can provide, let's say hello Java container. No, it's wrong. Container, like that, and run. Docker is started, and already you can see from the logs that you have hello Docker container, hello Java container, because you gave it a name. But here there is no name. You still in images. From containers you can see the name, it's changed. It's not randomly characters anymore. That's how can you run image using Dockerfile instruction. Next one, we will do exactly the same by running HTML file from Docker container. This one will be a bit different because we are using server to run this one. As moment so important, if you would like to run anything on Docker, we will speak later how can you check the instruction and the steps to follow using Docker. So see you next time for running HTML file. See you there. Stay tuned. This time we're going to run Docker for HTML page. Let's say how can we run our HTML page inside Docker. For sure it's just a dummy, but we will know more concepts about tagging, latest, what is built, and how can you build even if you are not inside Docker. We are going to open our Docker, this one, and creating a new page. We will call it just HTML. Nothing fancy. And in this case, let's open it within exactly the same approach, open with code. Here I have open with code, and yes, I trust this one. Close and close. We would like to create a simple HTML page. Let's call this HTML page, for example, also let's call it hello. Let's not complicate stuff. So hello.html. I believe that I have a content somewhere is ready. Yeah, it is here. HTML, I believe it will not be that complicated. This is the title, Dockerizing website. Hello from my Docker. This website is served by NGX server. Okay, now it's time to use Dockerfile. Usually you write your Docker file in the root of your project. Here HTML is my root folder. I will create a new folder and I will call it Docker file. It is exactly the same steps. There is nothing fancy. We will start by the keyword from. What will be my runtime environment? But okay, that's HTML. In this case, it will not be a runtime environment, it will be a server because HTML is a web application. It says the web page. So web page, in order to run, you need to serve it using some kind of server. In Java, it was a programming language. We needed a runtime environment. For HTML, it's also needed runtime environment, but this time will be server to run from. And let's say we will use server called nginx. So let's make it simple. I think it's ng, and we need to provide also something not complicated. We will call this one thing nginx alpine. Yeah, there is nothing. Let's keep it as it is, alpine. What will make this one more simpler than the previous one is just there is no command line to run. There is nothing to do at all because it's a server. The server will start automatically, and nginx automatically is using port 80. So remember that any server to run, this server, it will have a port so that it can receive requests from outside world. So in that moment, all what we need to do is just to copy. And if you remember that the copy is using source and destination. Source copy from where to where. Usually copy from local to image creation. The source will be my hello, but in lowercase, because that's what I would like to copy. Hello HTML. But where is the destination? Is the destination will be a folder within nginx server that's serving HTML static pages located in user, but we need to start by slash because this is a Linux command. So you start by forward slash user. So user and then share, or sorry guys for inconvenient, share and ng, I think nx and slash. Let's make this bigger. Why is not bigger? Let's make me slow. Okay, nginx and then slash nginx HTML, where it will be serving the page, and my hello.html. So this so simple command, in fact, is not complicated. You're just telling Docker on the build stage that please take this hello HTML and copy it inside this nginx HTML. By the way, 2 lines of code, and that's all what we need. So now our Docker is ready and everything is ready. How can we serve this image? That moment, I would like to serve this image from outside here. You can see I have the folder HTML and here is the Docker file. So how can we do that? Let's say that I will open my terminal and I will write Docker build. Docker build. I will call this one hello HTML. But now I will not let Docker using the latest versioning by itself. I will give a specific version by myself. That will be much better in the future to have a versioning for your images. So every time you create an image, you give it a different version if you have a huge change in your image, for example. Once you give this build, you need to specify where this file is reside. So I believe it's HTML and / enter. So Docker build required one argument. Yeah, because I didn't add the -t4 tag. Enter. Now it's running the image and exactly the same. Is internal, the first one from Docker, second one is already cached, but copy it from here to there. Because I did that before to test. So now my Docker image is existing. Let's double check it. Here is images and here below HTML. One is 12 minutes ago because I was building that before. Moment of the truth. Let's run this HTML. Exactly the same. Docker run, but what will be different this time? Well, let's use D, which means detach. So I can use the same command line if I would like to do it. If I didn't do detach here, I will not be able. So let's do it without detach. I would like to run it, but here is the moment and here is the point. Docker container is exposing port with port 80 for the nginx server, but when I will run it, I would like to tell it explicitly what port from my machine will be mapped to the port from the container. -b, it's shortcut of minus port. This one I will tell it from my machine, port 8080 from my browser. Please point it, link it, map it to port 80 from the nginx folder. And hello HTML 1.01. That's all, and enter. You can see I can't use this command line anymore because already it is busy with the server, so there is no possible to use it. If you use /d, you will be able to use it. But let's see what is going on. Docker desktop HTML is already in use because it's green. This one is not in use because it's not green. Containers, you can also see, and even here you can see the ports. It's mapped localhost 8080 is my local port, is my device, my machine. It is here right now. But 80 is coming from within the container, what the container already exposed. Now let's just click it and let's see what is going on. If you check it like that, you can see that you got already welcome to nginx. This exactly the welcome page for the server itself is 8080. But our HTML page, it is a pass within the server, which will be HTML, which will be hello. Yeah, exactly HTML. Enter. Now you should hello. You see now hello from Docker container. That's indicator that our image is working. So remember, if you would like to run your Docker file from any place outside of where it exists, you need to provide the path, for example, like that. If you will run the Docker file from within, you just dot, and that's it. That was a simple running of HTML page from within the container, and we saw by ourselves how can we achieve that. Let's stop it. There is no need, and we will continue later. So let's meet over there. Got you. Bye. Two more concepts now. First one, it's what if you are a full stack developer, but you are focusing on front end, or you are already a front end developer and you require from your back end team to provide you with a specific REST response. In that case, your backend team could provide you with a Docker file and or Docker image that you can run locally, and you will have already an interaction or interactive project that you can use it locally using Docker image. Also, how can you minimize the size of your image? By using Docker stages or step by step when you are building the Docker file itself and the Docker image, I mean, from the Docker file. How can you make that small? That we call it Docker steps. So here we will consider ourselves first of all as a developer that we would like to make this multi-staging Docker. I am preparing already in this Docker demo just a Java application. You notice that there is nothing running at all. You will find it as well on GitHub. So I'm running it inside my VS Code because I am not focusing here on Java itself. All what Java is doing is just a simple controller which provide me with two users already. Like one with by ID, second one is just getting all. It's a dummy because I am already in the repository mapping it by myself. So I'm not focusing on Java. We are going to build our Docker multi-file or multi-staging. So let's make a Docker file and let's already identify the stages. First of all, that's a Java application. We need to use the JDK to build the application, then the GRE Java runtime to run the application. So we have two specific stages. Maybe in your programming language you will have only one stage. Maybe you will have multiple stages, not just two. So that will be all depends. And how can we use that to use first stage to build the application, then read out of everything heavy, then we use a smaller runtime for the second part or the second stage. As usual, we are going to use from to provide it. But here, Java application, I'm using Spring Boot application, which is going to be built using file. It's called Maven is automation build tool. So I would like to have a build from Maven. I will ask for Maven, but let's make it all a smaller case and let's provide normal Maven and this Maven will be Maven 3 for example, and it will be Eclipse version, and I'm going to use Termin, but I will use Termin version 21 as builder. That's a stage one. The stage one is going to build the application. So I need also, as usual, to have a work directory. The work directory, I'm going to call it in simple word Docker. Let's just make a work directory inside, and I will call it Docker demo. I have the work directory. First of all, what I would like to do is copy the boom file into the internal application, into the internal folder inside the image using copy, and I will copy the boom.xml file is the file containing all my dependencies, so I can run it and then I will be able to download all the dependencies required for my application to run. After that, once you have it inside, you would like to run Maven. Why I'm having this copy boom XML here, it's for Java developers especially, is for caching purposes. Any change in Maven will be reflected. If you don't change Maven, it will be cached. That we will see right now. Let's make run command, and this run command is going to call mvn. That's a build command for Maven, the dependency, and I will call it go, let's say, offline. It's not required to make it go offline, but it will help. And please, let's give it B. Okay, so now I have it already running. I need to copy the source folder. So I will copy the src folder inside the Docker src folder as well. So now I have it here. I would like to run the Maven to build my application, not to build it. I already having the dependencies. I downloaded all the dependencies. I didn't use them yet. So Maven is downloading the dependencies and they will be ready to be used. Once I have the source, I would like to package my application by doing the following command: run mvn. mvn package is will package my application into jar file. I would like to just skip test, and even it doesn't make difference to skip test, but let's say /d skip tests. It will not harm to skip tests. Now you will have within your application stage one is done. Application is packaged, but it's not runnable yet. So now it's time to run it. Maven will use stage one. After that, we'll read out of stage one to go to stage two. So this Maven Eclipse termin is a JDK. It's containing almost everything. It's Eclipse JDK, which it's heavy. It's like maybe 400 megabyte or something. But stage two from, and in that case, I will use the same but in different. I need a runtime. I don't need Maven anymore. Maven is done. Maven built the application, package it. I need a runtime to run my application. from Eclipse. Also, Eclipse providing me this termin, but I need, okay, the termin, and I'm sorry, Tomarin, and 21 GRE Albine. That's image which I would like. It's still small. And I'm going exactly to repeat most of what is above here, but not in the same way. I would like to create a work directory. This work directory will be also the same, so I can just copy it from here, Control C, be lazy, it's something good. And that's my work directory, and it's time to copy the jar file. I built it something and I packaged it. I need to use it later. So I'm using the copy. Again, I need to make copy like that. But I would like to copy it from where? I would like to copy from by using this from. I'm telling it to copy it from which stage. The stage is the builder stage. To where is the target? I would like to copy it into my Docker demo, and I would like to copy every jar file from the builder stage into this Docker demo, and I will call also target within the Docker demo and all dot jar. So I got from builder, I have already a Docker demo folder, and I got from that one all the jar files to put them and name them. Let's call this one Docker demo snapshot. Snapshot.jar. So what I'm doing in simple words, I'm copying everything and I'm packaging it into this jar file or give it a name. So jumping later into port. Now our application will run, but this is a Spring Boot application is using server to communicate with controller. That's because you are a front-end developer, for example, and you would like to have some REST response. So how can you get REST response without port? So let's expose, it's already giving me the port. I will expose 80. Your application is ready, but you need an entry point. You need something to start this application. So we will write entry point will allow me to execute some commands similarly to CMD. So I will call it jar. I need Java because Java will run the jar file, and I will let it know that I would like to run this jar file, and I will give it name of my jar file. This is the jar file which I would like to. Now I have my Docker file is ready. That's stage 1 because it's starting from, and that's a stage 2. Usually your colleagues will not send you all this hassle because they are doing it on their side if you are a front-end developer. But if you are a Java developer who would like to provide this application to your colleague in front-end, you will follow these steps. So consider yourself both of them. Now it's time to run the application, but do I have something here in this Docker? It's telling me that this jar is something. When using copy with more than one source file. No, I don't think it's a problem. Let me double check it. Okay, so minus from builder. Yeah, Docker demo from target all.jar, and I'm giving Docker demo snapshot.jar. So it should work fine. I shouldn't have any problem with that jar file. Guys, that's normal. When you are working in development, sometimes you have a mistake, trial and error, and that's how you manage your application. Okay, now it's a moment of truth. Let's give it a try. I don't have any image. I don't have volume. I have nothing here. So let's build this application. I can build it from different ways, but let's say that I will build it from within the Docker itself. Here is the Docker file. It just created right now. And it's time to call the terminal, and let's try, or let's say the moment of truth. Docker build, and I will give it a tag because that's my image. I'm going to tag this image and I will call it Docker Spring, and that will be the first version. And because Docker file is within the same place where I'm running this command line, I just need to call dot and run. So there is something already wrong. I have it from builder docker target all.jar. Yeah, simply because I forget to add 2 minus here. So I believe that will be the issue. So now let's continue and have one more check. Let's CLS and run the same command once more. Should work this time. Exactly. Now it works. The reason why I got this cache because I didn't have any changes. I did that before during the test to make sure it works fine. So now I have my image is ready. I can provide this image to my colleague in front end, and my colleague will be able to run it using simple run content. Simple run command. If we double check it here, I will have the image Spring Docker or Docker Spring tag, it's version 1, ID, and it's created 30 minutes ago because I was playing around. And the size is 300 megabytes. Okay, so now it's time to run this image to double check it. But before running this image, let me show you as a front end that I would like to use it. I have already running Angular application, and this Angular application is listening to port 80. If I make like that, I have nothing. I have ID, user name, user email. There is nothing here to show. So let's put it down and let's run our Docker run, and I will provide it a name. Let's give it a name like a Docker Spring. Also, I will need the port because if you remember, we already exposed port 80 from within our server. So I will map it to 80 from my local machine to 80 inside the container. Almost I have everything ready. I don't need anything else. I have the name, I have the port, and just I need to run my application. So where is, yeah, it is here. Control C, because that's the image I will be running it. Enter. Now it should run fine, and as you can see, it is running already within because I didn't use again the /d to be detached. But Spring Boot application is started from the container because I don't have here anything to indicate other way around. If we go back here to our Angular application and refresh, voila, you got already two username and user email from within Angular application. That's one of the most powerful part of Docker, that you can simply build Docker image like this, send it to your colleague, and your colleague will be able to run it offline without the need to understand exactly what is going on in your application. Also the same for you, that you can do it for your colleague, also can do it for you based on what languages you are sharing, what kind of application you need. So really Docker is amazing by working that way. Also the cache part, you check here that we have it already 1 and 2. So you can see that cache stage 1 working directly, builder stage 1 already is done. Exporting to image, exporting to layers, and because most of that already cached, there is no change. If you make any change, this cache will be invalidated, or the specific stage will be invalidated, and then you will have Docker running once more. That was a quick how can you use Docker to cooperate within the same team. In fact, by just building the multi-stage application. You know now what is multi-stage application is a Docker file where you can find more than from I mean, and that will be multiple stages. So we will stop here to jump into later for Docker volume. How can you use real database? Because within this Spring application, I'm not using any database at all. So see you there for the database communication. Thank you so much for your time. See you. In fact, why multi-stages and not single stage? For you to get used to the best production practice. So you get used to do that on a daily basis. It provides the best of all worlds, as we say. Small size of the container or the image, high security, excellent reproducibility, and efficient caching. This is the modern standard, especially for microservices. Use single stage only for initial prototyping where you are working on your machine, developing it, or if the image size is truly doesn't matter for anything. Docker volume and how to use it. A Docker volume is a mechanism for persisting data generated by or and used by Docker containers. It is like an external hard drive that you can plug into your container to avoid the following issues. Any data created inside a container, for example files or a database, is stored in a writable layer on top of the container's image. When the container is deleted, that writable layer and all the data are also deleted forever. This data is also isolated from the host machine and other containers. We are using volumes to avoid losing this data when we removed the container. Key characteristics of Docker volume. Managed by Docker. Docker creates and manages the storage location on the host machine. You don't need to know exactly where is the path, but there is also an option to provide a full path, so it will be managed by you. Decoupled from containers. The volume's life cycle is separate from any container's life cycle. You can delete a container and its volume will be persisted. can be shared. Multiple containers can mount the same volume simultaneously. This is useful for sharing data between containers. High performance. Volumes are often the best performing option for write-heavy workloads compared to other persistence methods. Let's first demonstrate the data persistence and Docker volumes using Postgres as a database engine. So be ready, this part requires some attention. Let's get in. Remember that as a developer, regardless of which sector you are using database is something essential for any application to store data. So what if you would like to run some kind of specific version of a database locally, but in the same time you don't want to get into the hassle of installing it? That will be our task now. Let's say that we are going to install Postgres database using Docker. First of all, we would like to leverage Docker. Here is the command line. Let's make sure that Docker is running, and by just making like container ls. Okay, so there is something Docker container ls. Okay, so now Docker is running cls to clear the page. I would like to run image using Docker. Usually when you run image from the command line, you would love it to be detached, means that it's going to run in the background. But to show you what is the effect of detach, let's just running without detach. So we will provide -e, which means environment. I would like to provide an environment variable for that database, Postgres password, and I'm going to provide the most secure password ever, password. Now I would like to expose a port. Usually Postgres as a server is exposing to us for 5432 port. That's what we'll be using, -b to identify the port. 5432, that's a port from my machine, and I am mapping it to the Docker. So remember the golden rule, from your machine to the Docker machine, 5432, which means that when you run any application using local port of 5432, it should automatically get into the Docker container. Now I have the building block of my run statement. I would like to run which version of Docker. Let's say that I would like to have a Postgres, the name, and version 13. Now enter to run it. Unable to find the image locally, so it's going to pull the image from Docker Hub or from whatever registry you are providing. Once it's run, you see I'm already running the image directly. If you remember, we didn't provide -d. That's why this command prompt is already blocked and I have no access. I can't use it. Container service running and using it. If I would like to interact with the Docker, because it's a database, so I would like to check tables, to add table, create tables, whatever, the command to interact with the running container, you will use docker execute. But which container would you like to interact with it? In that moment, I don't know exactly what is the Docker name. I have no information what is the container name which is running right now. So let's remove the Docker execute and let's see Docker container to make sure and to check as well, and ls which container is running. I have name, it's called pedantic whatever. I don't know what this name. If you didn't provide specific name for your container, Docker will generate one for you. You need to interact with this Docker. So let's say Docker execute, and I'm going to provide this name by just Ctrl+C and Ctrl+V. What kind of command I would like to use inside this container? PSQL is a shortcut to get into the command line of Postgres itself, and -u because you need a user. Which user is currently this Postgres is registered or allowed to use? So we will use the default one from Postgres. It's called Postgres. Enter, and I can't execute with it. Yeah, because we need to provide IT -IT interactive. Enter, and now all from whatever users. Usually we always follow the command. Enter. Okay, there is nothing, which indicates that I am already interacting with my Docker container which is running. How can I know that? If you check the running container over there, you can see exactly the command you type, the running, the system, everything. Even here it doesn't exist. Okay, how can I know? Again, let's get into our Docker, the running Docker itself, and I will see that I have a container and I have an image. The container is running, it's green, and the image in use, it's green. And this Docker container, because it's a database, is creating something called volume. Volume is a place where Docker will store its data, tables, scripts, or whatever. We will speak about volumes later. So now our container is running with this random name. Okay, so let's get out of this container because it's not the point, is just to check it. To stop the container, let's just see Docker container, but which container to stop? I think Ctrl V will still the same. Enter. Docker container stop, and it is time to provide two important things to Docker container while it's running. Detach, so it can run in the background. I don't need to check logs all the time. And name for the container to give it a specific name which I would like to use in the future for any references. We'll provide exactly the same, but with adding the detach. Docker, let's say run /d minus and minus, let's say name, and we give it a name. Docker Postgres environment variable for Postgres password. Let's say password, but in a normal matter. Let's expose the port 5432 again for 5432. Image which I'm going to use is Postgres 13. Now, moment of truth. Run. Unable to find it local as well. We pull it from remote. Once it's run, I should be provided with a detach. Like now, you can see that I got something here. So let's double check together if we have Docker container running. Docker container and ls to list all the container on my machine. I have it exactly Docker Postgres 13, and this time I have already the name which I provided up here, Docker Postgres. Later on you will know why this name is really important, especially when you're running Docker Compose. I can do exactly the same like Docker execute, and I would like to execute this Docker Postgres. I would like to get into it. Control C, Control V. I would like also to get into the command line for the Docker itself by -u/user, and the user will be Postgres. Enter. I got nothing. Now I have it running, but I'm interacting with it using the command line. Now you will see the powerful of using Docker. You can interact with it from the command line. In the same time, if you would like to interact with Postgres using user interface, let's say like pgadmin is so famous for user interface interaction with Postgres database. So I'm going to catch it from here. Yes, pgadmin 4, and I will provide the server information. Using that server information, I will be able to create table, destroy table, and doing all of that. Page admin is running. I have no servers at all. Remember that I don't have any Docker, any Postgres on my machine. So from server, I will register a new server. The new server, let's call it also Docker server. The connection, it will be localhost because it is running locally, and the username is Postgres, the same username we use to enter the command line interface. The password, it will be the magnificent difficult password. Now I should be able to communicate with Docker using pgadmin. Let's give it a try. Voila, I can see that I am already inside Postgres. If I use the Postgres query tool while I am using this one Postgres database, and let's say I would like to create a users table. Here from within the command line, I tried it first time, it's telling me that this users table is not exist. So let me check if I have something already here somewhere. Yeah, I have create table users. I'm using two screens. So let's get into Postgres. From this query, Ctrl V. I have a users. I am creating that table, and let's run the moment of truth. Run. It's queried successfully. If we would like to try again by using select or from user, you see the difference. We already now interacting with PostgreSQL from user interface like pgadmin, and in the same time I can interact with it using the command line interface. That's a powerful of Docker. Now you can download, install any database in your machine without even having it physically on your machine. By this way, you can experience with a lot of different applications, programming languages, database systems, SQL, NoSQL, whatever you want. Welcome to the world of Dockers and the flexibility which is provided to us. Next time, we're going to dive a little bit deeper. We can make several components running together in a real life examples. Welcome to Docker Volume Practical Task. First of all, you need to make sure that you have Docker desktop is running. You can double check it from here. and if you see, yeah, this Docker, so Docker desktop running. Now you have it all. Let's get into Docker volume. Command prompt, and we would like to just install, or let's say make a container of Postgres image started by Docker run, and let's give this container a name. Let's say Postgres Docker, and let's use our environment variable for Postgres password and say Postgres password gives a magnificent password. And let's also expose our port 5432. I didn't use any detach because I would like you to see exactly what is going on here and what will be after we generating this desktop. Let's say that we would like to use a Postgres image version 14. So I hope it's okay now. I have the name, I have the environment, I have the port. So nothing else, and enter. So it should start. Yeah, I need to use only one dash here, not two. Okay. So Docker started. It's okay. There is no problem. If I have any issue here, it will be terminated. Now what I would like to check. Let's first of all check if we have Docker container is running and there is no issue. So Docker container ls to list all the Docker containers. Let me make it big and control scroll to make it more readable. As you notice, I have Postgres 14, I have the container, I have the name which I give it to the container. When you work with volume, it means that you have some kind of container which use data persistence. Docker will anonymously, if you didn't explicitly provide -v and provide a volume to use, it will be anonymously creating volume for you. How can we know that? Let's say that Docker and let's say inspect, because we would like to inspect this Postgres Docker to make sure that we know exactly what volume is linked to that Docker or attached to that Docker. Once you click inspect, there is something wrong with the word Docker as usual. Welcome to the world of programming. Now I inspect it. Volume means it's something gets mount into, because you use Linux now. Linux term, you search for mounts to check. Yeah, here is mount and here is the volume name, and you can see that the source it's exactly coming from within. I mean, this is the source which Docker will provide by default, and this is the destination. So Docker will mount this destination with that source. So remember and check D1F3. So let's control N to get N, and now let's check that we have exactly this volume, Docker volume ls. Once your Docker volume ls d1f33. So surely now that Docker already mounting this volume with that container. Let's say for any reason that you stop this container, Docker stop and Ctrl V for Postgres. You stop the container is not running and you deleted the container. If you stop the container, every instructions or every details will be still linked to the container. But in case if you remove the container, Docker M, Ctrl V. Now you remove the container. If we check that we have containers or not, ls -a to make sure that we can see all the containers. So now moment of truth. Yeah, container is wrong. No. Okay, now there is no containers, there is no image at all. But in fact, if you check Docker volume ls, you will still be able to see the previous attached anonymous. That's why, because when you're using command line interface, you need explicitly to tell Docker when it remove the container, which that container use another volume, that you need explicitly to delete the container with its own volume. So command line interface is more explicitly. But desktop, on other hand, it will be totally different. So let's go quickly to desktop to check that behavior. Here is my desktop. In desktop, I have the image, and let's create image direct container directly from that image. I will say let's run. I have the optional settings. I would like to give it a name. I will say Postgres desktop, for example. I will not provide any host. Let it create it by itself, 5432. And let's provide the password. I mean, that's how you can run a container from an image using Docker desktop. Exactly, there is no difference. You have some variables, some optional settings you provide. Run, and let's double check. It's running. Now it's inspect. Let's also search for mounts. I have mounts. You can notice that I have a new name. So BB06. If you check volumes, you will have it and you will have it green, which means that in use. But in use where? Container in use. You can see Postgres desktop in use. In that case, when you are using Docker desktop, if you delete the container, Docker desktop will handle that by deleting everything, because Docker desktop will assume that you are, as a user, you would like to make a system cleanup. So that's a different. When you use command line interface to delete or remove a container, it will keep the volume unless you delete it explicitly. We will check with that later. So now from here, if I deleted that container, there is no container. If you check volumes, there is no volumes which was attached to that container. So also I will delete this volume. I don't need it anymore. So delete forever. Now let's double check quickly also the same approach if we are using Docker desktop. Let's also do the same here. Docker run, but this time I would like keep it as it is. No problem. Now Docker is started. Let's just, I'm using arrow, up arrow to just make sure that I have everything. So going up and back. Docker container stop Docker Postgres. No, I will not need to stop it. I would like to inspect it. There is no such Docker Postgres. That's interesting. So let's make Docker container s minus a. So it's running and it's called Postgres Docker. So my mistake. Let's Control C and let's make Docker inspect to make sure. Docker inspect will give you the chance to get into the Docker to read the settings which it provided to the Docker. Control V. Now let's quickly check the mount, and also we can do the same. Here is the mount LE70. Even if you check the desktop itself, you can find it LE70. So it's moment now to remove the desktop. But from Docker command line interface, you have to be explicitly with each step. So you say Docker stop and Postgres stop. Now you say Docker m/v with the volume as well. Control V. Let's check that. Now you delete it. So let's make Docker volume s. Voila. There is no Docker volume. If you checked here for the desktop, there is no as well Docker volume. Okay. Now you know about the differences between running Docker desktop and managing, deleting, removing a container associated with volume. If you notice that behavior, once you delete the Docker container, you already lost the volume as well. So what about if you would like to have persistent data that regardless of that Docker delete, remove container or whatever you are doing with the container, you will always have that Docker volume. From desktop will provide you only with one option, unfortunately, that so far I can see, that if we come from image and let's say that we run, let's do exactly the same. Let's say the container name, I will see it Postgres desk, and I will keep also 5432, and I would like now to provide a path. Docker desktop is much easier. You can provide a path like this. And let's say that from documents, I would like to create a new folder, and I will call that folder Postgres desk. So here is the folder F2 Postgres desk. Now I know that on my folder I have this one, and let's select folder. I selected the folder, but the data which I would like to map it from within, it's simply the following data. It is where the Postgres serving the data, which is var and lib for library, then PostgreSQL after that data. So that's a folder where Postgres is storing data. Even you can see it locally if you have. If you remember when we make like Postgres inspect, we saw already that as a destination inside the Docker itself. And the variable which I provide usual is Postgres password, and let's provide the value of pass. So hopefully that everything is okay and I have the configuration correct. So var lib PostgreSQL data and run. In a moment of truth, if there is something wrong, I should have it like will stop, will not work, container. My container is running, there is no issues at all. And here is, there is no volume. Unfortunately, you can't see the volume here. But let's check if we inspect this container from the desktop now. I have the container. Let's check bind mounts. You can see bind mount this time is already mounting source. Let's use a host destination, which is a container. from this disk. Let's open it and check. Voila, you can see that already it is here and already is containing all the disk, the Postgres data. So if we say that, okay, I am fed up with this Docker container, I will remove it. I would like to have a new container, like a new version of Docker, of Postgres, for example, or whatever. But I would like to link it to the same. So this bind mount will not go anywhere because it's already stored in your local machine. You have it already where you want it. It is here. If we checked it, it will not go anywhere. It will be always in this local folder. So that's a powerful of using Docker volume. Now we knew how can we create that using the Postgres desktop. What about if you would like to do exactly the same from the command line? Command line is more flexible and more powerful. In command line, you can provide two different volumes. First one is managed by Docker. Second one is the same like bind mount that managed by you, because you know exactly where you store your Postgres. The only difference when you create a volume, you can create it from here, and it's Postgres Docker, and create. Now you have a volume here. If you would like to create a new one from command line, it's already stopped. Let's CLS to clean it, make it a bit bigger, and let's quickly call the rest. Yeah, Docker run, but in this time, I would like to map this one to a new port because this port is already busy with the previous container. So Docker run minus name, and I have the port, the path. It's time to give it a volume v, and when you make v, you need to provide volume name. So if you provide volume name, you say to Docker that I am providing you with a volume that you, Docker, you need to manage it, but you will not delete it unless I will tell you to delete it. And the reason why is much easier to give that because you name a Docker. If you remember, when we checked the name for the anonymous Docker, it was a huge string of letters. But now you will provide Postgres details. Let's get the name explicitly from here to not make any mistakes with name. Control C. And from here, I will provide it Control V. Time to bind. I would like to bind to the same exactly place. var PostgreSQL and data. In that moment, I should have this folder mount. I should have this Postgres mount to my folder. Enter and the moment of truth. So it is running. Database system is ready to accept connection. If we check the desktop again to make sure, yeah, you can see it is already in use automatically. Double check container in use. You have it already Docker container. Bind mounts. There is nothing bind mounts here. Why? Because I am telling Docker, you will manage this volume. I will not manage this volume. But this volume will not be deleted unless you explicitly delete it. Even if you make Docker remove from here, from desktop, this volume will not be deleted anywhere. You have to delete it by yourself. So if you inspect from mount, where is mount? Please come in. Okay, mount, and you can see already there is the name and there is a volume that you provided to use in desktop. You can exactly do the same from Windows here, but this part I will leave it for you. You can play around both of them. So let's now stop both containers, and I have the both containers. I would like to kill both of them. Delete. I don't care about them. So I deleted the containers. Let's check the volumes. I still have my Postgres Docker. Even I deleted the container from the desktop. And desktop usually will delete the container with its associated volume. But because this volume I created it explicitly, Docker will not delete it anywhere. So simple word, you can do exactly the same. But if you would like to create your own volume from command line, it's so simple. Docker volume create. Let's say CLI, enter. Now you have CLI. If you make Docker volume ls, enter, you have both of them. So this CLI will not go anywhere. It's named. You give it a name. You can also double check it here. They are both here. This one still contain data, 41 megabyte 05. What is the powerful of that now? That whatever you delete a container, whatever you did anything, now all what I need to do for next time, if I would like to create a container, let's say I will create a container from desktop, I will provide also the same, let's say this one new, it's totally new, Docker post, and I will provide those 5432. I will provide the volume path, which I have it, which is, where is my volume, yeah, Postgres disk, select folder. That container will be created with all the previous data has been mounted from the previous container. So by this way, regardless of what I'm doing with the Docker container, if it's Postgres or whatever, I will never lose any data because it's persistent on my disk. That's a powerful of Docker volume. So also you can do the same, by the way. If you would like to create a Docker volume from here, let's say that we would like to create a new volume, but instead, if I am, let's do something much easier. Delete all of that nonsense, as you will not see it for me. CLS, yeah, okay. So now Docker run, I would like to run, but this time I don't wanna that providing something like Postgres name. I would like to provide the same path I have it. All what you need to do, you will just need to go to your path, Docker desktop, here, Control C, copy, and then you go back to your Docker and let's say Control V and enter. Should work. You see, it's even telling me that Postgres database directory appears to contain a database, skipping initialization, because it's already have been stored before. So database system is ready to accept connection. It is working. I didn't get anything here, which means it's not terminated. Now, if I check desktop again, I have my containers is running. If I inspect that container binds mount, it's already bind to the previous var. So hopefully that was so simple. You saw by yourself now how can you work with Docker volume, creating, deleting, using desktop or using command line interface. Thank you so much for your time, and let's catch up for Docker Compose. It will be the next one. Catch you there. Docker Compose. Docker Compose is a tool for defining and running multi-containers Docker applications from a Docker file or images directly. You use a YAML file, dockercompose.yaml, to configure your application servers or services. Then with a single command, you can create and start all the services from your configuration, dockercompose.yaml, just Docker Compose up. Networking in Docker Compose. This is the most important concept here. By default, Docker Compose creates a single network for your app. Each container or a service joins the default network and is both reachable by other containers on the same network and discoverable for each other by the host name, identical to the container name. Now it's time to use Docker Compose to run several services simultaneously within the same exact network. When we are explaining also Docker Compose, we will see how Docker Compose provide us with a default network that we can use. And when you have been provided with a default network, which means that if you have some container to container communication, you don't need to export any ports. That's what we will see as well during this practical part. From the previous, we have already our full stack application is ready. We have Docker demo. But before getting into that, let's make quick refresh. I don't have any object coming back from the backend because there is nothing running. As well as here, if I make quick refresh, I will have nothing. So which means that I don't have any contact with the backend, with database, with nothing at all. Docker Compose, it can run service from Dockerfile or from Registry Hub. Creating Docker Compose file, and let's call it, okay, F2, Control A, let's call it just Docker Compose, and it will be a YAML file. Now we have this Docker Compose running. Let's open it with VS Code. Show more, open with VS Code. I have Docker Compose. Let me make it a bit bigger so when we tab you can see it. Docker Compose is to run multiple services. One of them, for example, will be database. If you remember from the previous episode, we spoke about volumes to persist objects. I would like to map volumes like we did before using the command line. Create just volumes, and let me call this volumes Postgres data. I have it already here, and I will make it. That's the syntax. And let's go to home. And now it's time to create our services. So Docker services, and first service I will have, it will be the database service. In fact, I have it prepared here. I will just copy it and explain it to you. So I have my database. I need to, yeah, okay, let's make it that way. to make sure it is shifted. And I have the database service and I need to give it image, environment, variable, volumes because they are not services. Just okay. So quickly going into service. Database service, it uses the image Postgres 13, container name Docker DB, environment variable to provide it to that container on the runtime. It will be the database name, the Postgres user, and the password, the magnificent, powerful password of password, and the volume which I would like to map from my local to the Docker container folder. The second service, it will be the back-end service. Also, let's copy it and explain it to you. Here is my second service. It will be the back-end service. Build.docker demo. If you notice the difference, I have the backend coming from build because here I am pointing to a Docker file within this path where it's located. I created Docker Compose here in this folder and it's pointing that I have Docker file inside Docker demo. That's a backend. Here is a Docker file. So that's why I use the command build in this moment. Here I used build. But with Postgres, I used image because image is coming from registry hub or somewhere I am storing this image online or offline. In case the backend team provided you with image, you will not use build, you will just provide image name. That's only different. Container name, I give it a name, Docker backend. It's better to provide always a container name for human readability. Environment, it's highly important. Why environment in that moment highly important? Because I am accessing database. I don't know where this database existing. So on runtime, when my application running is expecting to be provided with database information. So here is I'm providing Spring data source URL, GDBC Postgres, database. If you notice, I'm giving database because both of them are running within the same container. So it's container to container communication. So instead of using localhost, I am using the database name under the hot. It's going to be resolved to the IP address of that container database within that default network. And automatically, because it's a container to container, I didn't need to make any expose because both of them again are running within the same network. If I need this database to run outside of that network, I will provide here exports and I will export ports. So that's now Spring. I have the URL, where is my database located, username and password from the database. Depends on, it's highly important because it defining order of execution. Once you run the Docker Compose will check depends on, and then we'll see, okay, database should be up and running before the backend because logically you can't run backend service if you have a database and there is no connection with database. You will get error on runtime. Okay, so and ports, I'm exposing the ports of my backend 8080, and the reason why I'm exposing that port is because I am going to interact with the backend service from outside of the container network. So that's in fact, that's it for the Docker Compose services, and then you provide your services one after another, and then you provide the order of execution depends on what, and then you provide the volumes, and that's all. Now it is, as we say, moment of truth. Let's get into our command line interface. I think also control should be bigger. Okay, good. And let's run the container. All what you need is just a Docker compose up. That's it. And you run. Now it's pulling the database. My application it's starting, and the reason why I didn't do any -it to be interactive or detached is because I wanted you to see at the end what is going on with my application. So Docker Spring is running and I have no issues with Spring. Is communicating with my database and everything is okay. Nothing, no problems. I have even printed here one of the users by ID. And let's check together also reflection. I have it Angular application with no object in that moment. So let's make refresh. Once you refresh, all right, you got already some object from Angular application. Also, because we exposed 8080, we have also the same expectation here. In fact, that was it from Docker Compose. Now you can see by yourself how Docker Compose is really powerful tool that you can run multiple services within the same container. Quickly, let's double check the container from Docker itself. Here I have my containers. I can see full stack because I ran Docker Compose within a folder. This folder was called full stack. So that's why I have the main container full stack and two containers within that. If we check quickly DB inspect and we check networks from inspect, you can see the network settings, networks, and here full stack default. That's how it is. Also, if you check the Docker backend, you will see the same name regarding the network, full stack network. Where is it? Yes, here is it, full stack default. So guys, that was it for the practical part of Docker Compose. Hopefully that will be beneficial, and in the future we will continue working and I will show you how can you interact with Hub Registry if you require any specific image. See you next time. Thank you. Before finalizing, I would like to show you two important points. First of all, Docker provides us with something we call Dockerignore. If you know GitHub, you know Gitignore, Dockerignore are exactly the same. It's excluding some specific files to not be inside your Docker once you Dockerize. Let's say that you used to work with some text file, images, etc., but you don't wanna overload your Docker container, so you can use Dockerignore. Dockerignore resides in the same place where your Docker file exists. Let's quickly check it. And here is it. Let's say that Docker Angular, it will be a Docker file, and here Dockerignore. Open it by VS Code. Here is it. Let's say that I don't want to have .get, .getignore, node modules, this Docker file, etc. So once you run, Docker will check this Dockerignore file and will exclude all this file from being Dockerized. It's very important to reduce size for security reasons. Most of the time, maybe you don't need to Dockerize some credential or something. Okay. Another thing, and it's highly important, is how to use Docker Hub. Go to your search engine, write Docker Hub, and why to use Docker Hub. Once you click Docker Hub, let me show you the interface. Docker Hub will help you to find the image of your desire. I don't know exactly which image in mind to choose right now. Got some image which maybe will be better. Let's say MySQL, and let's get into Docker official image, MySQL. Let's see what's it. Yeah, here is MySQL, and there are some explanation maintained by who and the quick reference where the file issues, supports, etc. Also, you can find some examples. How can you run it? And here, how can you run XML in Docker Compose file? Image, restart, environment, etc. So in quick, that's how you can find any image you're looking for. Read the documentation. It will be much better to use a smaller image as much as you can and try to find the official image that will be more like valid and more secure, because usually it's official image, so it will be batched and it will be enhanced. My hub, it's a place where I can find my stuff, things I get to use, things I downloaded before, some expectations. I suggest you to use Docker Hub, sign in, because you can also finalize your image and push it, and you publish your image using Docker Hub. That was a quick how can you use Docker Hub. Please navigate it, check it yourself, make some exploration, play around, because this is the only way to learn. Don't just listen to my video and say, okay, I know it all, because it's not true. You have to try yourself, and I hope that course will add something good for you. So see you next time with another concept. Bye. Docker limitations, concerns, and mitigations. While Docker is an incredible tool, it is not a silver bullet. Understanding its limitation and concerns is crucial for using it effectively in production. Starting by security. Shared kernel vulnerability is causing a large attack surface in the base image. For mitigation, use minimal base image such as Alpine or Distress. Run containers as a non-root user. Regularly scan images for vulnerabilities like Docker scan. Implement runtime security monitoring such as Falco. Performance. Overhead from isolation, causing a potential input-output slowdowns. To mitigate it, use Docker volumes for data-intensive operations. Set resource limit for memory, for CPUs, and for containers as well. Data persistence. Its containers are ephemeral. Data is lost by default when you remove the container. To mitigate that, use named volumes for persistent data managed by Docker, or use bind mounts for development managed by you. Networking complexity. Containers network and cross-host communication can be complex. To mitigate that, use Docker Compose for development. Use an orchestrator such as Kubernetes for production, orchestration, and scales. Docker alone doesn't manage multi-containers or multi-host deployments. To mitigate that, adopt Kubernetes for orchestrations. By the way, that's the industry standard. Use managed Kubernetes services, EKS, AKS, GKE to reduce complexity. Stateful applications. Running databases in Docker adds operational complexity. To mitigate that, prefer managed cloud services such as RDS for production database. If running in Docker, use dedicated volumes and robust backup strategies. Image management. Images can become large and registries is really cluttered. To mitigate that, use multi-stage builds to reduce image size. Implement registry cleanup policies to remove old images. Monitoring and logging. Traditional tools aren't built for ephemeral containers. To mitigate that, ensures apps log to system out or system error. Adopt containers native monitoring like Prometheus or Grafana. Docker unlocks speed, consistency, and scalability. Now you have the key to modern development and the transformation of it works on my machine into it works everywhere. Go, build, ship, and run the future. Hopefully this crash course added some value to your knowledge. If it does, please share it, like it, and spread the knowledge. In Islam, we say that the charity of knowledge is to share it. Honestly, the course took me more than 2 months to prepare it, film it, editing it, having coffee, all the setup, lights, backgrounds, and and all this stuff. I'm hoping that really it will be beneficial for you and for everyone. Thank you so much for your time. If you have any questions, suggestions, enhancements, or ideas, let me know. Write it down in the comment section below. Let me know about your experience, about your experiment. How do you feel about that? Now, I would like you that you go enjoy the power of its running on my machine. Thank you so much for your time.